Hello everyone, welcome to our Climate Action app, which supports SDG 13 climate action. Let's take a moment to look at how this module fits into the bigger picture. At the heart of the entire application is our main menu built in the Climate Action app.java. This is the central navigation hub where users begin their journey and choose what part of the app they want to concentrate on. When the users launch the app, they're greeted with a clear text-based menu where they have three choices: Transport Emissions Calculator, the part which we will be discussing at length shortly. Option 2, Household Energy Emissions Calculator. And number 3, finally, Climate Tips and History. Of course, there also is an option to exit the app gracefully when they're done. The menu isn't just a list, it's an interactive and smart way of letting the users interact with the application. It uses user input validation to catch mistakes. So if a user types something invalid, they will get a helpful message and can try again instead of just crashing and freezing. One of the nicest things of this application is how it's structured using loops. After the user is finished using any module, whether it's calculating emissions to reading tips, they're given the option to be brought back to the main menu. This makes the experience feel smooth and consistent and encourages exploration. Maybe you just came in to check your car's CO2 output, but then you decide to explore energy usage at home, or read up about some climate-friendly lifestyle ideas. In that way, the main menu isn't just about structure, it's about user flow and discovery. And from a development perspective, it's modular. New features can be plugged in later without breaking the rest of the system. So whether the user is in module 1, 2, or 3, they can come back to this simple, reliable starting point. Now, let's begin with discussing our transport emission calculator, my part. In this part of the app, we focus on the emissions produced by everyday transport, from cars you drive to the bikes you might ride on weekends. Now let's explore how this module works and why it matters. We built this tool to give people a simple yet powerful insight, because they might wonder, how much CO2 does my vehicle use? You can just enter two details: the car you're using and the distance you traveled. And instantly, the app returns the amount of CO2 you have emitted. It's a part of our broader mission, helping users understand their personal role in climate change through tools that are grounded in data and awareness. This matters because it is one of the largest contributors to greenhouse gas emissions globally, especially in the UK, where private car usage is high. But here's the problem. Most people don't see the emissions they produce. If you drive 10 kilometers to work and back, it feels like routine. You don't get a receipt saying you have released this much amount of CO2 into the air. This is where the tool comes in to help the users calculate. This module supports 9 common vehicle types. So whether you drive a mini, a motorbike, or a luxury car, it's covered. It uses real-world data you loaded from CSV file, so the results reflect actual emission rates in the UK. The formula is straightforward. Emission equals to distance into emission factor. But the real value comes from the context. It translates your trip into a CO2 number that's easy to understand, and the result is presented clearly in grams of CO2, not technical jargon, just a number that means something and easy to understand. The vehicles that are covered by our calculator is mini, super mini, lower and upper medium, executive, luxury, sports, and dual purpose, and motorbikes, of course. Each of these separate vehicles have separate emission rates, so switching from one to another can make a difference over time. It is also helpful for comparing options. Thinking about upgrading your car, this tool lets you review its environmental cost. Now imagine you're using the app. You're asked, enter the vehicle type. So for example, Super Mini. You type that in, then enter the distance, let's say about 20. Behind the scenes, the app fetches the right emission factor for a Super Mini and performs the calculation. This keeps the experience simple and fast for users, but precise under the hood. Here's what you might see in the output. You have emitted 3.20 grams of CO2 by traveling 20 kilometers in Super Mini. It's clean, direct, and easy to understand. And once you're seeing your result, the app smoothly brings you back to the main menu so you can continue exploring the other options. The data set used to make this calculator is made from using data from verified UK transport emission factors. These numbers are derived from real research and surveys that take place throughout the country. By incorporating this real-time dataset, it makes the app more real and credible as a tool. This module is implemented in the Transport Emission Calculator.java. This class handles reading the dataset, asking for the input, doing the calculations, and managing any data like unknown vehicle types or invalid distances. It is neatly connected to our main menu, so the users can smoothly go back and forth between the modules. From the main menu, the users can access the transport calculator, check their household energy emissions, or explore climate tips and their history. It uses a clean looping structure, validating the input carefully.
After the first module, which focuses on transport-related emissions, I will now walk you through the second module of our project, which is the Household Energy Emission Calculator. This module estimates how much carbon dioxide is released from energy used at home. For example, from using electricity, cooking with gas, or running heating systems. It addresses a major aspect of climate change, which is indirect energy emissions from buildings, something most people don't realize contributes significantly to global warming. Many people think of emissions as coming only from factories or cars, but household energy use, like air conditioners, refrigerators, water heaters, and lighting, contributes a large share to international CO2 emissions. Even a small lifestyle change, like reducing electricity use or switching to gas-efficient stoves, can help reduce emissions. The idea of this calculator is to make people more aware of that connection by converting their energy use into an understandable carbon footprint measured in kilograms of CO2. When the user runs this module, they are first shown a list of energy sources, for example, electricity, natural gas, LPG, oil, biomass, or wood. Each energy source has a known emission factor, which is the amount of CO2 CO2 emitted per unit used. For example, using 1 kilowatt hour of electricity releases about 0.177 kilograms of CO2. These values are stored in a simple CSV file, which makes it easy to add or remove fields without modifying the Java code. The, tech, the CSV file is read using buffered reader in Java, and the data is stored in an array list of field objects. Each object contains three values: the field name, the unit it's measured in, and the emission factor. Then, the program displays the list to the user and prompts them to select the field they used. For example, they might choose electricity and then enter how many kilowatt hours they used in a month, let's say 400. The program takes this quantity and multiplies it by the emission factor. So CO2 equals to 400 times 0.177, which equals to 17.8 kilograms. This result is then displayed to the user in a clear format. Instead of hard-coding the field data, we designed this module to load values from an external file. This approach supports modularity and flexibility. If emission factors change in the future, or if we want to localize the app for another country, we can just update the file. We also created a field class to store and manage the field data using object-oriented principles like encapsulation. This made the code cleaner and easier to maintain. Each part of the module is focused on a single task: reading data, asking for input, calculating emissions, and showing the results. This module uses core Java features like file handling, buffered reader and file reader, array list for storing multiple fields, and custom classes and methods for clean separation of logic. One challenge we faced was extracting and simplifying the official dataset. The original the original file had hundreds of rows and covered many industrial fields that didn't apply to households. We had to carefully select only the relevant fields and clean up the database before converting it into a usable format. Another challenge was making sure the file path worked correctly in IntelliJ and handling errors like file not found using exception handling. Through this, we improved our understanding of file I/O, class design, and how to organize code for real-world use. In summary, this module plays an important role in the overall application by focusing on energy-related emissions at the household level. It combines object-oriented programming, file handling, and real-world data to help users better understand the impact and hopefully take action.
Hi, my name is Imran and I will be presenting Module 3 of our project, the Climate Awareness and Emission. So inside modules, this is part of our overall system, Ideal Emissions Estimator for cities, which focuses on helping user understand and reduce the carbon footprint. So in this module is a bit different from the other two. While module 1 and module 2 calculate emissions, and module 3 is focused on education and awareness, like directly supporting SDG 13, which is about climate action. We built this module to help users understand how their everyday choices impact the environment. It provides useful tips, helps people reflect on their habits, and shows international emission trends, especially focusing on the UK. So let's go over the core feature of this module. First, we can explore categorized climate friendly tips that are actionable and practical. Secondly, they can view the UK's historical greenhouse gas emission. Third, the module provides information about SDG 13 and UK's role in climate action. And lastly, there are an interactive eco checklist that gives the user a score based on their lifestyle choices. The emission tips section is divided into four main categories. For example, transport, home energy, lifestyle and diet, and digital habits. We selected these areas because they are highly relevant to everyday activities and behavior that people often overlook. For example, we included tips like reducing idling time or switching off unused electronics. And now here you can see an example of the transport related tips shown to the user. They are simple, direct, and meant to be easy to follow. These suggestions are also based on actual strategies encouraged by UK environmental agencies. So in this section, user can view a console-based bar chart showing how the UK's emissions have changed from 2018 to 2022. The values are simulated from DEFRA trends, and goals is to help to user understand that change is happening and that everyone has a role continuing the progress. We also have included simple educational screen that walks user through what SDG 13 is and why it matters. It explains UK's net zero targets and key climate efforts, but more importantly, it encourages individuals to take small but meaningful actions. This reinforces the educational and motivational goal of this module. The checklist is one of the main the which interact and which is interactive parts of this module 3. It asks user 9 yes or no questions that covers daily habits such as energy use, food choices, and waste behavior. This helps them reflect on their lifestyle and see where they stand. So here are some of the actual questions users are asked. So the first is, do you switch off lights when leaving a room, or do you recycle regularly? Do you eat plant-based meal? And like, these are not difficult questions, but they highlight habits that when improved make a big difference over time. So based on the answers, users receive a score out of 9. Depending on how they score, they receive a friendly personalized feedback. So suppose if they score between 7 and 9, they are doing a great, and if they score lower, the system gently encourages them to improve. This goal is to motivate, not to shame. All of this was built using Java, entirely console based and designed using object oriented programming principles. Each feature is implemented in its own class. For example, climate tips Java, emission history.java, ecolist.java, and so on. The controller class manages the menu and integrates all the parts. So here's the flow chart of the in my part for module 3. This diagram shows how the user follow and through the system. They start at the main menu and choose from four options. Each options have clearly defined flow and return them to the menu. This makes the interface easy to understand and use even for someone with no technical background. So to wrap up with, Module 3 helps user not just understand their carbon impact but also reflects on how they can reduce. Is also not just a tool but a guide combining facts, education, and interaction to support SDG 13. Technologies like they can really empower user to act, and that's what we aimed for here. So at we ended the module 3. So thank you for watching.